Hello friends, I welcome you in lecture number 36 on higher order ordinary differential equations. In this lecture we are going to solve this differential equation using the method of variation of parameters, and this question was asked in GTU Summer 2019 exam. First we write down what is given equation. Given equation is linear differential equation which is non-homogeneous, and it is a differential equation with constant coefficients. Y double dash plus 25y equal to sec 5x, and we give this number 1. To apply the method of variation of parameters, first we have to check whether coefficient of highest order derivative is 1 or not. Here highest order derivative is y double dash, and we can see its coefficient is 1. Therefore we are able to apply method of variation of parameters for this ordinary differential equation, and we consider this function on the right hand side. We denote that function by r of x, which is sec 5x. Now to find out solution of this equation number 1, we have to first solve the corresponding homogeneous differential equation. First we write down the differential equation which is homogeneous, and it corresponds to equation number 1. The corresponding homogeneous ordinary differential equation is, we consider right hand side equal to 0, and we will have y double dash plus 25y equal to 0. First we solve this homogeneous differential equation. The general solution of this equation is complementary function of this equation number 1. To solve this equation, we have to first write down the auxiliary equation of this equation, that we write by replacing nth order derivative by nth power of lambda and y by 1. Therefore we will replace y double dash by lambda square and y by 1. So we have lambda square plus 25 equal to 0 as auxiliary equation. To solve this, we consider this 25 on right hand side, that is minus 25, and we replace minus 1 by I square. Therefore lambda equal to plus or minus 5i, or this I can rewrite as 0 plus or minus 5i, and if we compare this with alpha plus or minus beta I, suppose this is equal to alpha plus or minus beta I, then we will have alpha equal to 0 and beta equal to 5. And we know that if we have a pair of complex roots alpha plus or minus beta I, then general solution is given by c1 e raised to alpha x cos beta x plus c2 e raised to alpha x sin beta x, and this is called complementary function of given non-homogeneous differential equation. So therefore complementary function is, now we put values of alpha and beta, e raised to 0x cos 5x plus c2 e raised to 0x sin 5x. If you are comfortable, you can directly write down this part without considering these notations alpha and beta. You can directly write down from this that complementary function is given by this expression, and e raised to 0x is 1. Therefore complementary function will be c1 times cosine of 5x plus c2 times sine of 5x. So this is the complementary function of given non-homogeneous equation, and here we have two linearly independent functions, and we denote them by y1 and y2. Let y1 is denoted by, let cos 5x is denoted by y1, and sin 5x is denoted by y2. and in the next step we will require the Wronskian of these two functions. The Wronskian is the determinant of these two functions and is defined as determinant with first row as y1 and y2, second row is their derivatives y1 dash y2 dash. y1 is cos 5x, derivative of cos 5x is minus sin 5x into 5. y2 is sin 5x, derivative of sin is cos and into 5 derivative of 5x which is 5. So it is 5 times cos 5x, and now we have to take cross multiplication. 5 times cos 5x into cos 5x, that is cos square 5x, minus 5 times sin square 5x, and minus plus, and we can take 5 common. So we have cos square 5x plus sin square 5x, and this is the identity, this is equal to 1. Therefore we have obtained that Wronskian of y1 and y2 is 5. Now we are able to decide the particular solution using the method of variation of parameters. We have ready-made formula for the particular solution or particular integral. So now we obtain particular integral. It is given by yp equal to minus y1. Inside the integral we have y2r over Wronskian integral with respect to x plus y2 outside. Inside the integral y1r over Wronskian integral with respect to x, and we substitute all these values. y1 is cosine of 5x, y2 is sine of 5x, and r of x is sec 5x that we have written in the beginning. Right hand side function is denoted by r and it is sec 5x. So here I substitute r equal to sec 5x. Wronskian is 5 integral with respect to x plus y2 outside, that is sin 5x outside. Inside the integral we have cos 5x which is y1. r is sec 5x divided by 5 integral with respect to x. And now in the next step we take 1 by 5 outside the integral, it is independent of x, and sin 5x into sec 5x, that I can rewrite as 1 over cosine of 5x integral with respect to x. Here also I can take 1 by 5 outside integral, it is constant or independent of x, sin 5x divided by 5, and this sec 5x is 1 over cos 5x. So let me write one more step. We will have cos 5x into 1 over cos 5x integral with respect to x, and this is equal to minus cos 5x divided by 5. Sin over cos can be written as 10 by the definition of tan function, and here I will have sin 5x divided by 5, and here integral of 1 with respect to x. Now we have the formula for integral of tan x. We know that integral of tan x is nothing but logarithm of sec x. So here I will have minus cos 5x divided by 5 into log of sec 5x, and instead of x I have 5x, so I have to divide by coefficient of x which is 5, and integral of 1 with respect to x is x, and I have sin 5x in the product. And in the next step I can rewrite this. I can take this multiplication of 5 2 times. So yp is now minus of cosine of 5x into logarithm of sec 5x divided by 25 plus x sine 5x divided by 5. This is the particular solution using the method of variation of parameters. And once we obtain particular integral and complementary function, the last step is to write down the general solution by adding complementary function and particular integral. Y equal to complementary function plus particular integral, that is yp, and therefore y equal to complementary function was c1 times cos 5x plus c2 times sin 5x, and here I can write this first, x sin 5x divided by 5 plus x sin 5x divided by 5 minus, here I have 25 in the denominator, cosine of 5x into log of sec 5x, cosine of 5x into ln sec 5x, and here c1 and c2 are arbitrary constants, where c1 and c2 are arbitrary constants. So this is the final general solution of given non-homogeneous linear differential equation with constant coefficients using the method of variation of parameters. Here right hand side function is sec function, so if they have not specified the method, then also we have to go for method of variation of parameters, because we cannot apply method of undetermined coefficients as well as shortcut method to solve this differential equation, because right hand side is sec function. So we must solve this equation using the method of variation of parameters, and it is very easy. We are able to find out integrals easily, and this question was asked in GTU exam, which was taken in summer 2019. So this is all about this session. I hope you like it. Thanks for watching.